Hello, physics, Mr. Alexander here. So for your homework, you had these two problems, and I'm going to go over them fairly briefly here. Feel free to pause the video at any time if you need to stop and think about things. So first one, we had a compact car here, mass 725 kilograms, and then the velocity. And I believe we talked about how to solve this. Um, let's see. So first we had to find the magnitude and direction of the momentum. So to find the magnitude, remember momentum is just mass times velocity, and then direction, if the car is moving east, then the momentum is east. And to show you, would just have to draw that. Okay, here's a picture. Velocity is east, which means the momentum is also east. And to figure out the momentum, it's right here. The only tricky thing is to convert kilometers per hour to meters per second. This is how you would do that. So let's see. Second car, actually just look at it here. Second car with a new mass has the same momentum. So now what we're going to do is we're going to take that momentum that we found, plug it in here for P, and plug in the mass of the new car, and then find velocity. And again, if the momentum was eastward, that means that the car has to be moving eastward. Hence, the answer is eastward. Next problem, number 2. We have this car, same car from before, hits the brakes for 2 seconds, and we have a force. And we want to know what's the question? Oh, there's the question. Man, dealing with babies makes you tired. What's the change momentum? Okay, so these are our bits of information. You can see delta t here and F. This should give you a clue that this is probably going to be an impulse problem because the impulse formula has delta t and F in it. So, to figure this out, here we go. Impulse equals the force times the change in time. And so the force here and the time 2 seconds, and we've got an impulse, and it's negative because when you're braking, you're actually pushing the opposite direction to the direction of motion, right? So if the velocity was eastward, the braking force is going to be westward, and that's why it was negative. For the sketches, well, this is what it would look like. Initially, you've got lots of momentum, and then after you slow down, you have less momentum because you have less, well, less what? Think about it. Less mass or less velocity? If you said less velocity, you're correct. So to figure out each of those momentums, here we go. Here's our formula. Force is equal to the change in time. Force is change in time. Ugh, I can't talk. Force times the change in time equals the change in momentum. Change in momentum is final minus initial. So solving for the final momentum looks like this. And there you go. So that's those.